Tim, thank you for that glowing introduction. Appreciate that. I don't know if you noticed as Tim was reading the title of the presentation, he had to stop and breathe several times. It's a very long title, and if I were to shorten it, I would simply shorten it to 2 words: the future. And that's how really we're viewing this. But in order to look to the future, we have to look to the past first. Here is a view of a much simpler day, a much simpler vehicle. It was a basic vehicle. The engine generated power. You created the vehicle, you loaded it up, and you went down the road. You did work. There was no greenhouse gas standard. We're as worried about the NOx standard. The engines were able to meet that, and there certainly was no OBD to worry about. All these things are things that have become our present, but weren't there in the past. One of the things that I will point out here is you will notice that there was a focus on aerodynamics in the past. You look at those mirror design, very much like some of the things you saw in the super truck designs. The only thing constant is change, and that's what our industry has seen. And the rate of change is coming much faster today than it ever has before, and the steps required in that change are even greater. Today we're faced with a whole lot of questions about what is changing, how do we deal with it, what's the impact short-term, long-term, how much do we have to change, what's it going to cost? And it's not just us as OEMs, but it's our customers as well. They're trying to understand what is the change that's going to impact their business. Today there's 3 programs that I'm going to be talking about. The first is one that is now in place or has been published. We know what it is. That's the Greenhouse Gas Phase 2 regulation. The second is one that's coming. We know it's coming, the ultra-low NOx standard. And the third is looking beyond that and what's possible in our future, and that's the Super Truck 2 program. There are 3 separate programs, but in reality, there's a huge amount of overlap. And we as industry, and hopefully regulators and certainly our customers, view these as having direct overlaps and direct interactions. So as we're doing our work and looking at these both from a regulatory development standpoint as well as product development and implementation, there really is a lot of overlap. And to be successful, the focus on the overlap is really what's going to drive us forward in the future. As Matt said in his presentation, when we look at the core of the regulation that being greenhouse gas regulation, it's really the same as what NHTSA has for fuel efficiency. It's about how much fuel is used to run a vehicle over a given duty cycle. In Phase 1, it was a very simple program. We had a standalone engine program. Put it on a test stand, you measured it, you got numbers, you reported it. On the vehicle side, you had 5 specific areas of technology that you could use for compliance. Put that into the GEM program and you got a grams per ton mile number and moved on down the road. As we've seen in the regulation, it's been a reasonably progressive but easy step for our customers. We look at it on the vocational side as really being about having knobs that we can adjust. We can twist the knobs to the left or the right. To the left, here for vocational, you have higher rolling resistance on tires. Move it to the left, you have lower. And it's a balancing act. You can turn some to the left. If you do, you have to turn some back to the right. On the tractor side, a little more complicated. 6 knobs: aero, steer tires, drive tires, speed limiter, weight reduction, and engine idle shutdown. And each of those is a balance both in terms of how we look at it as an OEM for our compliance, but also how our customers look at it and how we work with our customers in speccing their vehicles. Phase 2 is a little more complicated. On the engine side, those boxes that are green are really the ones that the agency used in phase one in setting stringency and OEMs used in compliance. The concept of waste heat recovery is a new one for phase two, and we see EPA including that in the stringency calculation. The vehicle side gets even more complex, more technologies added, more possibilities, greater reduction. As Matt showed in his presentation, the tractor side is at least 25% for some regulatory subcategories and vocational 24% reduction. Those are huge steps, huge movements forward for the industry, for the environment, and for our customers. So the number of knobs increases, and this isn't all the knobs, just a small sample of that. Those in green, again, are the existing phase one technologies, and those in orange are the new ones. And behind each of these knobs, there are more knobs. For example, tire inflation is really about automatic tire inflation or tire pressure monitoring. The engine has all kinds of different technologies that can go into it. Transmissions, is it a manual, is it automated, is it automatic? How many gears? What are the steps between the gears? What are the ratios? What's the efficiency? So it's knobs on top of knobs in order to determine both how we as an OEM work on our compliance, what strategies we want to use, but also for helping our customers. In the regulation, EPA identified a long list of potential technologies that can be used towards compliance and can be used towards helping the environment. On the engine side, some of the keys there are improvements in combustion, efficiencies with components and parasitics, updates to the aftertreatment system, and the potential to include waste heat recovery as a technology towards compliance. In tractors, of course, we would expect aerodynamics to be at the top of the list on the focus. But behind that, and really when you lump technologies together, the powertrain technology on tractors, when you look at engine, transmission, axles, tire size, axle ratio, the efficiencies of all these products, actually sums together to be over half of the stringency technology base that EPA used in setting the 2027 stringencies. Idle reduction continues to be a key point on tractors, and the addition of tire pressure systems is a new addition and an opportunity to keep the vehicle in a compliant state as it rolls down the road. On the vocational side, again, powertrain is a huge part of both stringency and what OEMs will be focusing on as we build our compliance plans. Idle reduction, stop-start technologies, and neutral idle are all new technologies to the vocational market for phase two stringency. In fact, the stop-start technology is brand new to the marketplace, period, especially on the heavy-duty side. That will be part of the technology forcing aspect of the phase two regulation. EPA also included some optional opportunities where additional testing can be done on transmissions to understand and use the efficiencies that are developed inside of the transmission and the rear axles to be able to help with our compliance effort. The powertrain testing, which is putting the engine and the transmission together on a test stand and testing the integrated efficiency between the two, can become another area for OEMs to use in our compliance strategy. With commercial vehicles, a tractor is not just a tractor. A vehicle running line haul is not the same for everyone. And that becomes part of the challenge for us when we look at selecting the technologies. I showed all the knobs and talked about the fact that they work both for an OEM on a compliance level, but more importantly, they work for a customer in terms of speccing the right vehicle for them. A vehicle running north-south on I-55 from New Orleans to Chicago is going to run about 1,000 miles. Over that course, they're going to see about a 400-foot elevation gain, 900-foot elevation gain across that. But that same vehicle running east-west on I-10, I-20 from Phoenix to Fort Worth is going to see nearly 5,000 feet of elevation gain. They both may be hauling the exact same load, but the difference in the spec can be dramatic in order to provide the most efficient operation for the customer. So the challenge for us as we look at the technologies is how can we help our customers make money? How can we put the most efficient vehicle in their hands? Because that's how the environment is going to gain. It doesn't gain by one size fits all. It gains by putting the right specs into the right job. And that really becomes our challenge. That's part of why we as OEMs are really focused on a 50-state program. We want a vehicle that's compliant when it's sold in Nevada to also be compliant with the exact same specs if sold in California or Connecticut or New Jersey or Washington. It doesn't make any difference where. Our other challenge is looking to the north. We're responsible for vehicles going into Canada as well, and they've got a new regulation that they're going to put forward. Their market's different. They run heavier. They can run up to 140,000 pounds of gross combination weight without a permit. In the US, that's 80,000 pounds. So the spec for those vehicles, the terrain, the weather conditions, make for speccing very different and our compliance different. When we look at ultra-low NOx, there are four aspects that we believe are very important as we go forward and look to the future. First of all, how the regulation is written. What are the components of it? How's it formulated? What's the test cycles? And then once we understand all of that, what's the stringency? What's the standard that we're being measured to? Then we as an industry need to look at how do we comply? What are the technologies, again, that we put into play to be able to reach this new level? And of course, in the end of the day, we need to focus on our customer. The customer is the one that buys the vehicle. If they don't buy, the environment doesn't win. So we have to make sure that whatever standards are set to help the environment also have a focus to the customer, because they need to be able to make money. They need to be able to have a reason to buy new vehicles in order to make the improvements. Again, we look at it as a nationwide program. You know, the roads go all over, and the vehicles follow those. To create a cutout of small areas here and there create great complications for us as OEMs, for our selling dealers, and most certainly for our customers. It also can influence the marketplace in ways that are not ones that are favorable for the economy or for the environment. There are lots of questions out there, as Dr. Bill and Matt both indicated. And we need to answer those questions up front as we start down the path of developing this ultra-low NOx standard. The why, who, where, when, what, how, and how much are very important questions for us to understand as we go forward to set the correct regulation to help the environment in the correct way. SuperTruck is really looking to the future. Today we want to look at what's possible. And through the exploration of what's possible, we can develop and determine what is viable for the future. SuperTruck One was a fantastic start in that process. There were 4 projects that were created, and every one of them attained wonderful results. Shown here is the Cummins Peterbilt vehicle, and you can see proudly proclaims the 10.7% fuel economy gain with real-world loads on-road, real-world conditions, but it's one truck. To say that all trucks can get to 10.7 and all these technologies are possible in the future is unrealistic. Many of these technologies, though, have moved forward, and we will continue to push that envelope. And that's what SuperTruck 2 is about. 4 awards were given. Shown on the screen is an excerpt from DOE's press release announcing those awards. The same companies that were involved in SuperTruck 1 as lead contractors have won awards again. You can see, looking at the list, there's a variety of different ways of attaining the goals, of attaining a 55% brake thermal efficiency over a 65-mile-an-hour cruise cycle, or creating a 100% improvement in freight ton efficiency over a 2009 baseline vehicle. All will stretch and look at the different and unique technologies, and then as a result of the project, it will help formulate what is the future, what is the possibility for the future. Some of the potential technology areas that will be seen are shown here. Aerodynamics certainly is a key part of that, but it's not just tractor aerodynamics, it's tractor and trailer. And the real advances come when the two are combined. Driver assistance through the ADAS programs, advanced technologies in tires, lower rolling resistance, weight reduction over the tractor and the trailer, management of idle, keep the engine off when it doesn't need to be running, find other ways to provide the heating, cooling, and electrical loads. High efficiencies through integration of products, managing the total energy package of the vehicle, managing airflow through, under, over, and around, creating engines that are more efficient than today, may not look the same as today, may not have 6 cylinders. We don't know. We need to look at that. And then creating the advanced after-treatment system to be able to control the additional pollutants, not just focusing on CO2, but the full gamut of pollutants. And once we have these technologies and have these demonstrated vehicles looking at the possibilities, then it's about harvesting the technologies to bring them into production so that the environment and our customers can gain from the work that's been done. Shown here are a list of possibilities for things that might be harvested and gotten into production in a timely basis. These are examples of some of the things from SuperTruck 1 that have made it into production, as well as some opportunities to stretch on SuperTruck 2. The things that we've been looking at here, whether it's greenhouse gas phase 2, the ultra-low NOx program, or SuperTruck 2, is really about building the future. Each of these are important pieces in creating that future. But they have to work together. They aren't separate. They truly are working as one. And where they overlap, that's where we have the opportunity to make the greatest strides forward. That's where we have the chance to truly create a win-win-win scenario. A win for the environment, a win for the agencies and OEMs, and ultimately a win for our customers. Thank you.
Thank you, Dan. So we have a few minutes to address any questions you have for Dan in terms of how PACCAR plans to address these future challenges. I'll start with a question, as is my way. Dan, you look ahead to greenhouse gas phase 2. You've said there's lots of knobs and dials you can turn to address those challenges. Do you think that there'll be a particular point in time, the 21 or 24 or 27, where there'll be a greater burden? Do you see a particular point at which the cost increase will be more substantial than the other steps? I'm thinking there, if the customers will stop, is there potential for a pre-buy and a kind of disruption to the market at any of those steps, or is it going to, do you think it'll be phased in as smoothly as EPA hopes?
Excellent question. Let me break out my crystal ball here and see what it says. Phase one, as it turns out, was really about picking the low-hanging fruit. I think 2021 and maybe 2024 might be like coming up to an apple tree and climbing up inside the tree and starting to pick the fruit. I think 2024 may be like setting up a ladder on the outside of the tree to get to the fruit that you couldn't reach from inside. And 27 may be like having a cherry picker come in to help you get the fruit off the top of the tree. I think that each step becomes more of a challenge because I use the word easier, but the technologies that already exist are being used more readily and having been used up. And more of the technology, forcing technology development, forcing that EPA envisions in this comes in the latter portions of the regulations. I think 27 in particular is going to be the largest challenge for us along the way, and I think that our customers will see maybe a greater push in technology. But ultimately, if we can do everything ideally, our customers say, great technology, it adds value to me, it adds money to my bottom line, bring it on. That's the hope. Matt's going, yeah, that's it.
That's the intention. Any final questions before we move to the break? No, I think it's been a very informative session, all three, and it's time to have some refreshments. So, Dan, thank you very much for sharing that view with us, and we wish you well for phase two.
Thank you. Appreciate the opportunity.